All right, now we're videoing. All right, this is lesson 18. So page 89. Ratio word problems. We've already done some ratios. And when you think about a ratio, there's always a ratio problem on the ACT. So ratios can be written like 3 to 5, or it can be written 3 to 5, pretty bad 5, or it can be written 3 to 5. Okay? And so you can see this in different ways in different textbooks. Just depends on what textbook. On the ACT, a lot of times the ratio is 3 to 5. That's how I see it. All right? And with the ratios, like if we said boys to girls in a particular class. So if the ratio of boys to girls was 3 to 5, and I said, so that would be 8, and then I said, in this particular classroom, there are 48 students. How many of them are boys? All right, so I would always build, this is called a ratio table, right? And you just add the ratios to get the total. So 3/8 really is how many boys there are. However, if you can see a scale factor, then use it. So what do I do to 8 to get to 48? Times 6. So every number times 6 is going to be what this column is. So it would be 18. How many girls? 30. We add them and get 48. So many of these problems, even on the ACT, are easy to see. So on one ACT, you know, I am always tutoring 4 weeks before the ACT, and it's this Saturday. And I only use live old tests. And in this test, it said, when x was 6, y was 9, and it was a linear function. Then it asked, when x was 2, what was y? This is the ratio field, all right? So what do I do to 6 to get to 2? Divide by 3, or I take a third, right? Same way, I multiply it by a third. So that was bad to write that as an x. It's really the y, huh? The y coordinate point would be 3. All right, so these really, if you build a table and write as you read, shouldn't take that long. Some of the wording in the book is kind of crazy, but let's look at our examples. Let's look at 18.1. All right, it says the ratio of Arabians to mixed breeds. So we have Arabians, we have mixed breeds, was 2 to 17 for a total of 19. All right. It says, if there are 380 horses, that's total, 380 horses in the herd, how many were Arabian? So really it doesn't matter how many were not. All right, look at this. Everybody look. When I cover the 0, can you tell what 19 times something equals 38? 2. So it's times 20, right? So I just take 2 times 20 to get to how many Arabians I have. All right, so what if I cannot see what my multiplier is, if I hide my zeros? I could just take 380 divided by 19 to get that value, right? I could do that 100% of the time. Make sense? I can always find my multiplier. All right? let's look at the second example, 18.2. Now we're going to have chemical mixtures. And in this textbook, it always includes some chemistry, except we don't look at significant figures. And it will get to some physics as well. All right, so 18.2 says 600 kilograms of sulfur. So I'm always going to have sulfur. I'm always going to have some other components to get to a new compound. All right, I'm always going to have those three. So it took 600 kilograms of sulfur to make 3,000 kilograms of the new compound. So how much other material did I have in there?
2,400.
2,000, yes, 400 other. And then it says, how many kilograms of other materials, so that's what we're solving for, would be required if I make a new compound of 4,000? All right, can you tell what the multiplier is? Okay, what if I multiply by 4 over 3? The 3 eliminates. That becomes 1, right? 1,000 times 4 is 4,000. So it's 4/3 times 4/3. You could have written 2,400 over 3,000 equals x over 4,000. You could have written this out, and you could have cross-multiplied, right? But if you can figure out a scale factor, I say do it. All right, I'm going to simplify. 3 goes into 3, 1, into 24, 8, right? Now, 800 times 4. I just want to multiply 8 times 4, which is 32, and I just add back in the 2 zeros. So it's 3,200. Make sense? I appreciate the table because it really helps you in ratios. All right, we apply the same concept when we have similar triangles. Remember, if I have all the angles of a triangle are congruent, then their sides are proportional. So if all the angles are equal, then I have similar triangles. All right, such that in the example 18.3, so this is sort of geometry review, I just have to match up the corresponding sides. So this is 4, 5, and 7, and this is 3, x, and y. And remember, the largest side is always opposite the largest angle, right? The smallest side is always opposite the smallest angle. So I'm going to first write these, the lengths of these sides, the sides in this triangle on the left down. Then I'm going to write from this triangle the corresponding part. All right, so what corresponds to 4 in this triangle? 3. What corresponds to 5? X. And what corresponds to 7? Y. All right? Now, I really could do that and cross multiply and solve for this. But what do I multiply 4 by to get to 3? Over 4, right? Because my 4s would become 1. 1 times 3 is 3. So I could take 5 and multiply by 3/4, See, otherwise I would have to have two complete equations. I would have to put 4/5 equals 3 over x and cross multiply. And then I would have to put 4 over 7, these outer numbers, equals 3 over y, cross multiply, and solve. But if I can see a multiplier, a scale factor, then I'm going to use it. So 5 times 3/4 is what? What's 5 times 3/4?
15/4.
Yes, 15/4. And 7 times 3/4 is what? 21/4. So I didn't have to work out two completely separate problems. All right, so you could calculate that scale factor.